Greetings and welcome once again to my new calculus channel. My name is John Gabriel, and today I'm going to be addressing a question that was posed to me by a new friend that I've made in the United States. Now, he's actually a fellow American. So, he asked, what is the difference between f of x like that and f prime of x? Well, they actually both happen to be functions. And the only reason that we write this prime here is to show that there's a relation between the two. What's the relation? Well, the relation is this. If this function f of x is that, then this function f prime of x, okay, this function f prime of x is made up of the slopes of this function. So it'll still be the same x's, but mapped onto the slopes. We didn't have to call it f prime like that. We could have just said fp, for example. Okay, fpx, and that means the derivative of f of x. Now, how do I know that your moronic mainstream math professors don't understand things? Don't understand these? Because for centuries they wrote stupid stuff like this: f of x plus h minus f of x is equal to the integral from x to x plus h of f of x with respect to dx. Okay. Now, because they're such utter baboons and morons and imbeciles who've never understood calculus or mathematics, they've never realized that the correct way to write it would be to put a prime there and change this into a little f. Okay. Well, since I've been bombarding them, they have made some changes on the Wikipedia entries, etc. But usually in the past, they would use a capital F here and a little f here. So it's just notation, by the way. And I'll explain to you how all that works. Don't worry. Now, suppose that f of x is this blue function and that we want to find the derivative. Well, let's put a trace on the red dot. See, that's the derivative. Now, by the way, you're wondering what this little dot's about. I'll explain to you in a moment. It doesn't really matter what function you use. So let's say you take a function like x cubed for x to the 4 minus that, minus that, maybe plus 1. Okay, something like that. And there again, now that red function there is just the slopes expressed in terms of the red function, okay? So this blue function here is f, and this red function here is f prime, all right? That's all it means. That's all it means. Now, if old Newton decided to do things differently, okay, and what I mean by that is he could have chosen to, instead of representing slope as rise over run, he could have represented it in terms of angle. And had he done that, let's go back to the previous function just to make things simpler. Had he done that, then every derivative would fall between pi over 2 and minus pi over 2, okay? That would be the range of so here you see, because Newton expresses as rise over run, the derivative is this red curve. But if he expressed it in terms of angle, then this is how it would look. Watch. It would look like that. See that? And it would always fall between pi over 2 and minus pi over 2, okay, between these two lines. It doesn't matter what function you have. it's just going to fall between these two lines. All right? Any function you like. Doesn't matter. So let's take another one just for the heck of it. Let's take log of x. Like that. Okay. Let's move it along there. Where did my little dot go now? My little yellow dot. I don't see it anywhere. Okay. It's probably because it's a little far out. So let's see if we can bring it in. Somewhere here. It's got to be somewhere here. Okay, it seems to have disappeared. All right, never mind. Let me go back to what I had and bring that dot closer. Like that. Hang on a second. All right, so let's put this right over here, like that. And now let's put log x. Okay, now if we move this guy, you'll see that this is how, get rid of the red one. Okay, so we'll turn the red one off. See, and this is how it looks. This is a derivative in terms of angle. Okay, this is a derivative in terms of angle. Right, but in terms of newtons, rise over run, that's the derivative. Okay, so log of x and its derivative, this guy. All right, so basically that's all that this means, that this f prime means. It's just a mapping of x onto the slopes instead of onto the original values of the function. It means take the tangent line slope at this point and map it to the x. Okay, so it takes the tangent line slope here and maps it to this guy here. Okay, that's all it is. All right, so I hope that helped you, my dear new friend. I don't want to mention your name just to keep your identity covered. Who knows, they may hunt you down and put you on a blacklist like they've done with me. I'm the great John Gabriel. If you're not already a subscriber to my channel, you're an idiot if you don't become a subscriber. So click like, follow me on Academia.edu, tell your friends about it, pass this on to your idiot math lecturers and teachers so that they can become smarter. And that's pretty much it. Till next time.